I got one.
Yeah, Andrea, let's go.
All right. 7x squared minus 40x minus 12 of 7x squared.
Over? You said over 7x squared?
Yeah.
Oh, okay.
Minus 12x minus 4. And that's all.
Okay, so again, we're trying to cancel across a division symbol. What do I need?
You could factor.
We need multiplication, exactly, so we could factor all this. What do we think?
I don't know how to factor it.
This one's a little hard. What do we think? Melissa, Quentin, Rachel, any ideas?
I think you would probably have to do AC method.
You want to try the AC method?
Mm-hmm.
I see Quentin's microphone turned on. Did you have an idea, Quentin,
What?
for how to tackle this problem?
Nah, I don't know how to do it.
Okay, so I'm gonna go with Rachel. You're gonna have to walk us through the AC method. Talk to us about what it is and why it works.
You would do 7 times negative 12, and that would give you negative 84, and you would put that in the x thing that you do. Yeah. And then on the bottom you would do negative 40, and you try to find two numbers that multiply to negative 84 and add to negative 40, which I think would be 2 and negative 42. And then you rewrite the first equation to 7x squared plus 2x minus,
Hang on a second.
minus 42x minus 12.
Okay.
And then I think you would simplify it again by putting parentheses around the first two numbers and the last two numbers. And then in the first set of parentheses, you can take out a 7x, which will leave you x inside with a negative 6. And then plus a take out a 2. And it would give you x minus 6. And then you can rewrite that as 7x plus 2, x minus 6.
Now tell me why I'm able to rewrite this line as this line. What's the logic? What's the meaning, and how are you keeping it the same?
Because you have two of the same ones, two of the x minus 6.
Okay, so we agree that multiplication is nothing more than grouping, right, everyone? Ooh, maybe not right, everyone. All right, somebody tell me what 5 times 4 means. That's what it is. What does it mean? How'd you get that?
5 times 4.
How do you do it? How would you explain it to somebody who's never seen multiplication before? What's it mean?
It's like
5 4 times. 5 plus
Yes.
5 plus
Perfect. Quentin's hitting it right on the head. That's exactly right. It's 5 4 times. It's 5 with 4 groups of 5. Like, it's 4 groups of 5 or 5 groups of 4. That's the other reason why we could write it as 4 times 5. So the meaning is that I'm repeating this grouping over and over again. Now notice here, in our polynomial, which looks much, much more complicated, I have 7x groups of x minus 6. Do you agree, Rachel?
Yes.
And here I've got 2 groups of x minus 6, right?
Mm-hmm.
So doesn't it make sense that I would say I have 7x and 2 groups of x minus 6?
Oh, okay.
So that's what it means. Now, everybody who's maybe watching this, if you feel like everything that we did here and here and here looks like magic, then you need to go back and watch the lecture video where I talk about how the AC method was discovered and why it works. But I can prove to you that it is true for the following. If, just like I said, I have 7x and 2 groups of x minus 6, then now, like saying I have 7x groups of x minus 6, that would be like I have 7x groups of x, which would be 7x squared. 7x groups of negative 6 would be negative 42x's. 2 groups of x would be 2x's. and 2 groups of -6 would be -12. And if you combine all of this stuff together, you get 7x squares, 2x's, taking away 42x's leaves you with -40x's and a -12. We're right back where we started. So you can almost kind of do this way if you're looking at it and going, okay, I see that it works, but I don't understand why. We're going to call that proof by intimidation because it seems to work, but we don't understand why. If you would like to understand why, which you should, go back and watch the How the AC Method, the AC Method video that I did for lecture. That'll talk about how this was discovered. It's really, really cool. All right, all in all, we are confident with saying that I could rewrite the top without changing the meaning as 7x plus 2 times x minus 6. Do we agree?
Yes.
Great. All right. Andrea, did you follow everything Rachel was kind of talking through about how to do the AC method there?
The only thing I was confused about the AC method is how she get -42 and 2.
Oh, that's a good question. Rachel, speak to that. How did you find these?
Well, I do like a guess and check on the -84. So I put -84 on the calculator and just first divided by 2. And the first answer that it gave me was -42. So then I was just like, does 2 plus -42 add to like my middle term, which was the -40, and it did. So that's a number those are two numbers that multiply to the -84 and add to the -40.
Did you follow that, Andrea, or do you have questions?
Yep, I followed it.
Okay, here's what I'm going to recommend both of you do moving forward to help communicate what, Rachel, you were just saying you did. I love what you did, but if you do things in your calculator, if you're trying to communicate it on paper or in test, I can't follow what you do on your calculator, right?
Mhm.
So here's what I recommend you do instead. Organize it like a table, or at least show me some scratch work of the things that you're trying in your calculator. So I like to start with the -84, just like you said, and then try to do some of that factoring. And I like to sometimes do it as like, okay, 1 and -84, and then you said, okay, it was 2 and -42, and then you're like, oh, there it is. And then you can show me, and then I get to kind of follow along in the story that you're crafting. Do you see that?
Mhm.
All right.
Okay.
Include something about how you got those numbers, because I would agree with Andrea. It looks a little bit mathematical right now, but if you can put it in that table, or if you can write that on the paper, that's where it's really clear communication.
Okay.
Okay, good. So somebody needs to do the AC, or actually, Andrea, you should do the AC method for the denominator as well, right?
Yeah.
All right. Why don't you talk me through how that would look?
So do 7 times -4.
Okay, 7x times -4 would get you.
-28.
Okay, so if we're going to organize this in our kind of cross here, on the top we've got -28 is what we need to multiply up to. We need to add to what?
-12.
What would that be? Should we try some numbers?
Yeah.
What are some numbers we can try that multiply up to -28?
128. -4 times 7.
-4 and 7?
Yeah.
Did you try 2?
2 and 14. And that'll get you 12.
Yeah, it will. Where's the negative need to go with, the 14 or the 2?
The 14.
Perfect. So that's a nice way to kind of communicate the thoughts that you were trying there. I liked how you organized all that out. Now, here's a couple of tricks, by the way, for everybody listening in. If you want to know a way to factor quickly, here are some tricks for factoring quickly. Dividing by 2 is as easy as telling me if this number is even. If it's even, then it divides by 2. You should try that, and you should put it in your table. Do you know a quick way to divide by 3?
Mm-mm.
If the digits in a number add up to something that divides by 3, then it divides by 3 as well. So take a look at this 84. What's 8 plus 4?
12.
12. Does 12 divide by 3?
Mm-hmm.
Then I know that 84 will divide by 3. I don't even know what it is, but I know it's going to work. Somebody do it in the calculator. What's 84 divided by 3?
28.
So it works. I knew that, and I didn't even have to know how to do it. Now that's a trick. That's a trick that has actually a pretty difficult math proof behind it to learn. So I'm going to give that to you as a trick. You can just have that one and keep that one in your mind. But that's a way to check if it divides by 3. So now you got if it divides by 2, it's going to be even. If it's 3, if the digits add up to 3, then it divides by 3. Or if the digits add up to something divisible by 3, it divides by 3. If Let's see. How would I know if something divides by 5 easily?
Ends with a 0. I don't know.
Ends with a 0 or
5.
or a 5. Good. So now you have the way to check if it divides by 2, divides by 3, divides by 5. After that, you pretty much covered most of the early, or you've covered all the early primes. So it's a nice way to go through these things quickly. You don't even have to check if things divide by 4. They divide by 4 if they divide by 2 and divide by 2 again. So you can go through all these ones and really make this table go fast without having to write too much on the calculator. At least that way you know what to be typing into it. Okay, we're running out a little bit of time, so I'm going to help expedite the process. So we've got, let's see, 7x squared. You were going to write that as a negative 14x, a plus 2x, and then a minus 4, right?
Yep.
And then what can you factor by grouping for the first two?
7
All right, 7 and
minus, wait,
somebody lend the assist. What can we factor out? Greatest common factor.
An X.
Do you agree?
yeah,
Okay, what are we left with?
x minus 2,
Very nice. And then if I do it for this next one, what will we factor?
2,
Leaving me with?
x minus 2.
And then all of that would be factored because I have 7x groups of x minus 2 and 2 groups of x minus 2. So how many total groups of x minus 2 do I have?
7x plus 2,
7x and 2 groups of
x minus 2.
x minus 2. Can you factor any or simplify anything in our early fraction now?
You could cross out the 7x plus 2.
How come?
They're gonna be equal to 1.
Good, because something divided by itself equals 1. We're canceling out multiplication with division. That's why we're allowed to do it. So I write down my answer as x minus 6 over x minus 2, right?
Yep.
Do you need to write restricted values for that one?
I don't know, do we?
Yeah.
Why?
That was on the homework. It says restricted values on here.
Okay, but I don't care. I'm not going to let a computer tell me what to do.
I mean, I do restricted values is at the bottom. I just do 7x squared minus 12x minus 4 equals 0. Then I plus 4 plus 4. Do all that.
All right, I'm cool with you telling me that's how you do it. I want to know a why before I begin. I don't
Oh,
trust
why
you.
we
I'm
do
feeling
it?
skeptical. Math is about
Because
why. It's not
see
about
if
doing.
it's-
That's for computers.
And see if it's like undefined or something. Or
Rachel, what do you think?
I think it's because when you cross it out, you're saying that it equals 1, right?
I don't know. Does it?
Because basically you're saying 1 over 1 equals 1.
You're not saying
you
1 over
can-
1 equals 1. You're saying the same number over itself equals 1.
Uh-huh, yeah.
Okay, good. Is that the case?
Well, you don't know because you have an X, right?
Is 7x plus 2 divided by 7x plus 2 enough to get me a number over number, same number equals 1?
I don't know.
All right, so here's the last little trick. Is any number divided by itself equal to 1?
Not 0.
Okay, perfect. So if you want to cross this off, then what you are telling me is that this is true for all numbers. If you're saying it's not true for all numbers, you need to tell me what number it's not true for. So what number is it not true for?
Would you put the equation equal to 0 and solve for X?
So you're saying if 7x plus 2 equals 0, then what we just did up there does not work.
And then wouldn't you like add 2?
Well,
I mean,
trying to get
subtract.
x alone. Subtract
Yeah.
2.
I subtract 2 and then divide by 7.
What'd they get you?
Negative 2 over 7.
Okay. And so what happens at negative 2 over 7?
If it's in place of the X, then it's going to equal 0, which means that since you can't have 0, that's your restricted value.
And you can't have 0 because?
Then it would be saying 0 over 0, which is undefined.
Right, and not equal to 1. So
And
the
yeah.
whole idea of saying I'm going to cross this off because it's 1 is true only if x is not equal to negative 2 over 7.
Mm-hmm.
So you can only say that this whole thing is equal to the beginning thing if it has all the same information, all the same meaning. And you're saying, here you go. This is the same meaning. so long as x is not equal to negative 2 over 7.
Oh, okay. So in every problem, you have to write the restricted values?
In any problem where you change the meaning, you've got to make a notation that you change the meaning because you're essentially reinterpreting the problem. And here's the way you can try that. Try plugging in x equals negative 2 over 7 into this problem, okay?
Mm-hmm.
If you do that, you will get an error in your calculator because you will try to divide by 0.
Mm-hmm. Oh, okay.
But if you try to plug in x equals negative 2 over 7 into this stuff over here, it will work, won't it? Negative 2 over 7 minus 6 is a different number than negative 2 over 7 minus 2, and so that's going to get you a number, right?
Mm-hmm.
So how can you say that a thing that doesn't work is the same as a thing that does work? The answer is you can't.
Mm-hmm.
Why we put that notation of a restricted value, we say they are the same, except for the place where they're not.
Oh, so that's why you do the x equals and then the slash?
Yeah, the x not equal to. That's what it means, is not equal to.
Okay. Okay.
Does that help out, Andrea?
Yeah.
Okay, cool. But I want to see if we can talk through this one. I'm gonna pull on some people, and I want us to talk about this one. The question is it okay for me to do this? Janaya, what do you think?
I think yeah, like
How
cross
come?
multiply.
Cross multiply? I didn't multiply anything. I just crossed things
Or
off.
did you like you subtract it because it don't equal 0, or they just cancel out?
I don't know. I'm asking you. Can I do this? You got to tell me a reason. Melissa, what do you think?
Doesn't it just equal 1?
How come?
Because anything divided by itself is 1.
Do I have something divided by itself?
16.
16 is being divided by itself? Because it looks like I've got a whole bunch of stuff on the top being divided by a whole bunch of stuff on the bottom. Do you have enough to say that it's 16 divided by itself only?
Oh no, but like, I don't know.
So what do we think? Can I do this?
I think.
Are we all feeling a little bit unsure now?
Kinda.
Kinda. All right. Here's the thing I like to do whenever I don't remember if I have a rule correct in my mind or not. I'm going to try it with numbers because these are all just numbers. Do we agree?
Yeah.
All right. Let's try with a number. Somebody give me a number for x.
3.
3. All right. Yeah, I'm going to do 3. You do 2. 3 minus 16 over 16 minus 3. What does that equal?
13.
Negative
13
Negative 13 over
13.
over 13.
over 13. Okay. That equals negative 1.
Yeah.
Does that equal the same thing as 3 over negative 3?
Yeah.
Oh, maybe it does work. Okay. Well, I can cross off like this. Could I do it like this? Could I do 3 plus 4 over 4 plus 3 is the same thing as 3 over 3 equals 1?
I think so.
Okay, let's try it this way now. Is it okay if I say I have 5 plus 4 over 4 plus 1 is the same thing as saying that I have 5 over 1?
No.
Yeah.
All right, what's 5 plus 4?
Oh no, that's not the same thing.
No, it's not. So this is a perfect example of the traps that we can get into when we try to approach math with rules. Even if it looks like it works with one problem, even if it looks like it works with a bunch of problems, if we don't know why it's true, we run the risk of sometimes thinking it's true when it's not. So instead, what I suggest we do is I suggest that we build this up from a place of logic, and that way if we started with something that's true and we end with something that's true, it must be true. And I'll show you why it is that it worked for these other two examples and it didn't work for this third example. So here's the first thing I want to ask you. What can you simplify over division? What does division cancel away? What's the opposite of division?
Multiplication.
Multiplication. So if I have some multiplication happening, I'm allowed to simplify over division. What if I have subtraction? Does division cancel subtraction?
No.
No. So that's the number one big flaw for why this and this didn't work. Or it might have worked, but it just worked by happenstance, and this one didn't work. So instead, we need to be talking about writing all things in terms of multiplication. So here's my question. Let's see. Andrea, I know you said that you saw that these looked kind of the same. I'm gonna pretend they are the same for a moment, and I'm gonna ask myself, what would I be missing? Hold on, I gotta clear that one up. What would be missing to make them the same? So essentially, if I want to have something in math, no problem. Let's just make it happen. But I have to handle the consequences. So what do you think I could multiply by x and negative 16 to get me a positive 16 and a negative x?
One, right?
Well, 1 times x would be just x, and I need to make it a negative x.
We need a negative.
I would need a negative. I would need to have a negative 1 right here, wouldn't I?
Yeah.
So if you do this, now on the top, do we agree that we just have a number?
Yeah.
And on the bottom, I have multiplication. In fact, I could even write it like this if you wanted. We could write this as 1 over negative 1 times x minus 16 over x minus 16, couldn't I?
Yeah.
And then now I have something divided by itself exactly, and we know that when we divide by ourselves, we'll get what?
1.
We get 1. So here I have it. I've got 1 over negative 1 gets me a negative 1 times 1. Negative 1 times 1 is?
Negative 1.
Negative 1. Notice why that worked for all of these. Do you see the common pattern now? These all worked because I had the same amounts on the top and on the bottom. But the moment I changed the amounts, it didn't work anymore because I didn't have the same thing. In other words, what I was really doing was I was disguising the fact that what I really need to have is a similar amount on the top, and that only when the amounts are on the top can I simplify them up in a specific way. But the way that they're oriented is really talking about if it's a negative or a positive. Do you see how now this kind of connects why it worked twice, but it didn't work the third time?
Yeah.
Okay, so instead of working from a place of seeing numbers and trying to cancel them off because we know that there's a rule, ask yourself, what can I use division to cancel away? I can use it to cancel away multiplication. Do I have multiplication yet? No. Can I make it into multiplication first? Sure. What would that give me? Do you see the difference?
Yeah.
Okay, good. That was a really fun discussion. I love this one. This is a number one common problem because it has like the logic, it's got the rules, it just kind of gets a little bit crazy sometimes. I call this one a cat and milk problem. Do you know why? Or a cat and milk mistake. Do you know why?
Why?
Because I had a teacher in high school who told me that his kid, who was 5 years old, he came home one day and his kid had poured milk on a cat. Right? Because that's exactly what a 5-year-old would do, right?
Yeah.
And it's like, okay, why? Like, that was the first question. Why did you do that? And the kid looked at him real simply and said, well, the cat likes milk and enjoys licking itself. That's a perfectly reasonable reason to pour milk on a cat in a child's mind, right?
Yeah.
But we kind of ignored that there's like context and everything else around here. This is the same idea. If we see things in front of us and we run at them too quickly, yes, we started from a place of trying to make sense out of it, but sometimes we lost the bigger picture. All right, Makia, let's go ahead.
All right, so it's going to be 3x cubed minus 24 over 6x squared plus 12x minus 48 multiplied by 8x plus 16 over 3x squared plus 6x plus 12.
Okay, and it would like us to simplify this, right?
Correct.
Notice the barrier that's keeping this from being able to be simplified. Right now I have addition and subtraction on the top and the bottoms, right?
Right.
Again, over here as well.
Okay.
And then I've got division between them and multiplication happening. So,
Right.
Andrea, I'm going to call back on you because we had the similar question that we had talked through. What's the problem with trying to simplify across a fraction if I only have addition and subtraction?
Yeah.
You got to get it, what?
I said, can you say it again?
Sure. So right now we want to simplify all this stuff, but it's in fractions. What's the problem? What do I need to do before I can simplify across a fraction?
Mm,
Fraction means what?
Divide.
By
What's the only thing I can simplify across the division?
Can you multiply?
I don't know. Andrea, what do you think?
yeah.
Okay, so we got division and multiplication cancel out. In other words, what we're going to try to do is if we want to simplify this across the fraction, we're going to look at all of this and say, how can I rewrite all of this using multiplication only? In other words, we're going to factor it. All right, so here's the question I'm going to be asking you, Makia. How can we factor this, or how can we make this look like as much multiplication as possible?
How can we make the left side look like multiplication?
Let's start with the top left.
Okay.
Anything you can factor here?
No.
Anybody? Do we see anything?
So it'll be. Can you do negative? Well, no, maybe not. Negative 8x cubed? Or no, that won't work.
Negative 8x cubed. Where are you getting that from?
Well, never mind. Maybe you can't do that. Never mind.
What do we all see, people? What can we factor?
I mean, we could do soap.
You okay? How come?
Because it has a 24 going something. Because it's like cube.
I heard something from Rachel. What'd you say, Rachel?
Can you do a 3? Factor out a 3?
Ooh, I've got difference of opinions. Let's see if we'll try it one way and try the other. Okay, the question is, can we factor out a 3? If we did factor out a 3, that would be what left over?
X squared minus 8.
X squared minus 8. Where are you getting the squared from?
I mean, x cubed, I mean.
X cubed minus 8. Good. Okay.
Yeah, that's what I kind of was thinking.
Okay, but Andrea thought that we could do something with that SOAP acronym. What can we do with the SOAP acronym, Andrea?
We can do 8 okay, 2 is
That's what I call it.
if you multiply 2, 3 if you 2 cube is 8.
Ah, so you're saying this is a cube.
Yeah.
This is a cube number. And is this a cube number?
Yeah.
Yeah, so we have a difference of cubes, don't we?
Yeah.
And that's exactly right. There's a formula that I proved for you why it's true. It's really difficult to see why that one's true without the proof. But we do know that it works because I can go backwards from it once I know about it. And that's exactly what we can do here. We can factor this out using the difference of cubes. What would be the difference of cubes after you did it?
X minus 2. And x squared minus 2x plus 4.
All right, let's check. Same. We're starting with the same symbols we had it here. Opposite, do we have?
Addition.
This should be addition.
Yeah.
Okay, good. Same opposite, and then this one's always positive. That's our little acronym for remembering how it is that I can factor out a difference of cubes. I like that. So that's going to be the top part of this problem. So that's my fully simplified, that's my fully factorized numerator for my first part. No problem. Who wants to tell me how we could factorize or how we could factor the denominator.
By 2.
And pull 2 out. What's
Yeah.
left?
3x squared plus 6x
Wait, couldn't you take out 6?
plus 24.
I don't know. Can you?
Yeah, I'm pretty sure you could take out 6.
Andrea, what do you think?
Does it matter? Really?
Why?
Well, wouldn't it be simplified, like, if you took out 6? Or,
I don't know. What do we all think?
I agree with Melissa.
I agree with both of you.
Or maybe you could also factor Andrea's simplified, like factor out a 3 out of the.
Yes, perfect. You can factor out another 3. Factoring out a 2 and then factoring out a 3 is the same thing as factoring out a 6. Very nice. So it doesn't matter. If you just keep trying to whittle this thing down, you're going to get there either way. All right, so I can factor out a 6 either by factoring out a 2 first and then a 3, or a 3 first and then a 2, whatever. And then how can I factor this quadratic?
You can. Oh, don't you can do x plus 4, then x minus 2.
How come?
Because 4 minus 2 is 2, and 4 times 2 is negative 8. I mean, 4 times negative 2 is negative 8.
Does anybody have any questions about how this got, how we got this?
No.
Quentin? Melissa, how you feeling?
good.
Okay, so we got this idea here. It comes from the AC method. You could organize it. Did you do these numbers off the top of your head, Andre, or did you start with like some other numbers you tried?
I started off the top of my head.
Okay, this is the first one you tried was 2 and 4?
Yep.
Okay, I would recommend that you show people how it is that you could try this out as if you were going to teach it to someone else. So organize it in a table where you can talk about saying what's going to be multiplying up to negative 8, and you could say, oh, I could have 1 and negative 8. I could have 2 and 4. I could, or 2 and negative 4. I could have negative 4 and 2. And you could be like, oh, never mind. If I make this one positive, this one negative, I found a solution that works. So show a little bit of kind of how that comes from. But I'm perfectly okay with saying we could factor the entire denominator as 6 times x plus 4 times x minus 2. Okay? Just don't make it look like magic, because then people who get lost will have a way of being able to follow your thought process. Cool?
Yep.
All right. So now, let's see. Somebody else. Let's see. I'm going to throw this one. Melissa, can you take the numerator here? And then Rachel, can you take the denominator here?
Okay.
We're gonna split up the workload here.
For the one on the right?
Yeah, I want you to take the numerator of the right fraction. Rachel's going to take the denominator of the bottom fraction. And then Andrea, I'm curious, how do you know that this part doesn't factor anymore?
Wait, which part?
This x squared plus 2x plus 4. Could we factor this anymore? It looks like something that I would want to.
Yeah, you can. Wait.
Okay, tell me what that would become. I want as much multiplication as possible so we can simplify. That's what you're going to be playing with, and then I'll come back to you when you're ready, okay?
All right.
So do you want me to go first?
If you got it, sure.
Aren't we just like taking out the 4
4 from what?
from the numerator?
Okay, so that's going to get you, I'll put it in a different color. We'll do, I don't know, pink.
Or
So you take
8,
out
I'm
4,
sorry.
what's left?
No, not 4, 8.
You want to take out 8, because we could take out 4, we would just need to eventually take out 2 more, right?
Yeah, but that doesn't.
All right, let's take out 8. What's that leave us with?
X plus 2.
All right, that's going to be 8 times x plus 2. Good. I'll put that in black down here. That one's a pretty simple one.
Yeah.
All right, anybody get theirs?
Yeah. You take out the 3 for the denominator, and you're left with x squared plus 2x plus 4.
Can you factor that anymore?
No,
How do you know?
because no numbers multiply to 4 add to 2.
Andrea, what do you think?
Yeah, that's correct.
Okay, so we see that just because things look like quadratics doesn't mean they factor out more and more. In fact, if you actually tried to use the quadratic formula with something like this, you would hit a similar problem. What you had just said is a great way of thinking about it. There are no numbers that would form this rectangle, in such a way that I could factor it out nicely. If you tried to solve the quadratic formula for when you were trying to set this thing equal to 0, you would similarly end up getting solutions that were not real. And it's because you've created something that literally is nothing but, and I erased it all, nothing but positive components through the entire thing. Okay. So it's okay for me to multiply fractions by just multiplying the numerators across and the denominators across, correct?
Yep.
Like if I wanted to do 1/2 times 1/2, that would be 1/4, and I do that from 1 times 1 and 2 times 2.
Yep.
So
Yeah.
same thing here. Let's multiply straight across. In fact, instead of rewriting it, I'm just going to connect them all like this. There you go. Now I can do all of my cancellation over this that I would want. So let's look at things on the top and bottom. X minus 2 could cancel away on the top and bottom. X minus 4 cannot cancel away. I don't have anything to cancel that one with. I could cancel away my x squared plus 2x plus 4 with this one. I cancel away the x plus 2. Oh, I'm going too eagerly. Let's take away this x minus 2 right here. There we are. Cancel those two things away, those two things away. I think that's it. So all in all, I believe we would be left with 8 times x minus 2 divided by, on the bottom there'd still be 3 and an x minus 4. So we could say this entire thing is equal to 8x minus 16 over 3x minus 12. And then we would need to say that we're accounting for all of the times that the things we crossed away could have been 0, because that's in fact not true to be able to cancel away things on the bottom and the top that could both be a 0. Let me throw that over to Rachel. Why is it true that I can't just always say x plus 2 over x plus 2 is equal to 0?
Because x can be negative 2?
And if it was, what's the problem?
It equals 0.
And what's the problem with that?
I know it's a restricted value, but I don't know what restricted value really means.
Okay, good. Let's dig into that. If x is negative 2, what is this value?
0.
What is this value?
Oh, 0 as well.
What's 0 divided by 0?
It's undefined.
That's exactly right. It's not 1. It's undefined. So we can't cancel this away and say it's 1 for everything if for one of these values it's not. So this is one time when it's not. We'll put this in. Now, this one we would also need to check here, wouldn't we?
Uh-huh.
Now, here's the way that I check this one quickly. Go ahead, Rachel.
Because you canceled it out? Is that why you're checking it?
Anytime you're crossing something away, you're saying that it's 1. That's what something divided by itself canceling away means, is that it's equivalent to 1, and multiplying or dividing by 1 doesn't change anything, so that's why we stop writing it.
Oh, so you get your restricted values from the numbers you cross out.
Right, because what I've said is that this whole thing, whenever I put these equal signs between stuff, it means that everything I started with is equal to everything I end with. And that's not true if I've changed the meaning. And I've changed the meaning by removing these problems. So we've got to talk about the problems a little bit more bluntly.
Okay.
Now, here's the question I have for you. We would need to check that for this one as well, right?
Yes.
Here's how I do that quickly. I don't even need to do a lot of math for that one. Here's what I think about. Is this a positive number or a negative number?
Positive.
Is this a positive number or a negative number?
Positive.
So I've got positive number plus positive number gets me a?
Positive.
Positive number plus 4, is that going to be more positive or less?
More positive.
Could I ever get 0 with that process?
No.
So if you actually throw this into your quadratic formula and you try to solve out when does x squared plus 2x plus 4 equal 0, and you go through all of that process, you're going to end up finding out that it's not going to work. You're going to end up getting a square root of a negative, and there's not a real solution. But logically, what's happening behind the scenes is saying, this can't be 0. It doesn't work. You never could make it happen. So in truth, there's not another restricted value. This is the only one that could possibly be 0. So you say, this is going to be my answer down here, and it's coupled with this simplified form. This thing with this has as much information as everything above it.
Oh, what if the 4 was a -4?
Then we could absolutely get an answer for that one. And it would not be a nice answer. It'd be one you'd have to calculate using a quadratic formula.